Hello! Hello, everybody! Welcome to the LIUniverse. I'm Dr. Charles Liu, but please call me Chuck if you'd like. It's such a pleasure to have you all with us today. And this episode, we have a tremendous guest, and we can't wait to talk about it and all the cool science and maybe some other stuff too that we're going to do today. First, let me welcome our wonderful co host, Allen Liu. Allen, hi there. Thank you so
Hello.
much. Thanks for doing this as always. It's really a pleasure and really glad you're here.
Yeah.
And you have a special role to play in all the things that we do. So thank you so much. Really appreciate it.
Yeah, you're welcome.
And having Dr. Sam Grunblatt as our guest today is a really extra pleasure. I'm so happy to have you. Thank you so much for being here, Sam. Thank you.
Yeah, thank you guys for inviting me. I'm super stoked to be here.
Tell us what your tell us what your research is based on. Is there a particularly interesting thing that you're working on right now that we should all know
Sure. Yeah. I mean, I always think so. But
about?
so my research really focuses on trying to understand the evolution of planetary systems, and in particular, the very latest sort of stages of planetary evolution. What happens, when a planet dies, so to
Mm,
speak. And so, what I've been working on is basically trying to find planets around red giant stars. So, again, for a little context, the sun right now is just sort of a main sequence star. But in 5 billion years, it's going to get much larger. It's going to become cooler and become more red. And basically, it'll evolve into a red giant star.
right.
And so, what I want to understand is what happens to the planets around the star when that change occurs.
Huh.
And so generally the thought is that this will cause some changes in how the star and the planets interact. And that can usually result
Yeah.
in the planet getting pulled in closer to the star or, going from a more eccentric to a more circular orbit. But it also changes how the planets might interact with one another. So you can imagine as the planet or as the star pulls on one planet, that might, then affect any planet that's, in between the orbits of those two planets. And
Yeah.
in general, you just have sort of more interactions between the individual planets, and that can actually make the orbits more eccentric instead of
Oh,
less eccentric. And so you have this kind of confluence of effects from both the
right.
star and the planets in these systems. And so that's something that I've been studying recently. And so most recently, I published a paper on three of the hottest Jupiters orbiting of all stars. And so these are really hot planets that are on less than 3 day orbits in two cases,
Whoa.
3 day orbits around these giant stars. And so
That's
they're
crazy.
not really great places to be.
Yeah.
Um, I hope I don't offend too many people by saying this, but because they're kind of so hot and don't have a whole lot of life ahead of them, I kind of
Uh-oh.
think of them as planet Florida. Um,
Oh
No, 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 no. You can't say that.
no offense, Florida is a very nice place. It has good people. Um, but yeah, so these planets are they're on they have a very short lifetime. In one case, actually, one of the planets that we found is expected to basically fall into the host star in less than 1 million years, which
Whoa.
in Earth timescales is quite some time, but
Yeah.
on astrophysical timescales is essentially a blink of an eye. It's
I'm putting that on my calendar right now.
yeah, it's
yeah.
less than a thousandth of the lifetime of the star,
That's
for
amazing.
example.
Yeah, what we have a lot of times is just this conception that as the sun grows into a red giant, it just eats the planets. It eats Mercury, it eats Venus, Earth falls in. But you're saying it's much more complicated than that.
Yeah, so it kind of it all depends on the star and the planet and the whole sort of system properties. But generally, if the planet is more massive, that means that as the star evolves, that it's going to have a stronger effect on the planet. And basically, you can imagine
Hmm.
that like in a scenario where maybe Mercury or Venus could just kind of hang out until the star swallows it up. A planet more like Jupiter is actually going to have to, react to the star getting larger, and that usually
Ah,
results in the planet getting, the planet orbit getting smaller and the
hmm,
planet getting
hmm.
closer to the star. And so
That makes
that,
so
that
much
sort of
sense. Well, today's joyfully cool cosmic thing is right down your alley, Sam. a candidate third planet, about 1/4 the mass of Earth, has been discovered, or at least a paper has been published announcing its discovery around the star Proxima, also known as Proxima Centauri, which, as many of you know, is the closest star to the sun. That is amazing, really cool information. Sam, you have to tell us, how significant is it that now there are 3 planets that we think exist around Proxima, which is like this tiny, tiny little star. You can barely even see it. Uh, even
Yeah. It's pretty amazing, I think. I mean, only a few years ago we didn't know how many planets there were outside of our own solar system. I mean, we
Yeah.
still don't necessarily know how many planets are in our own solar system, but we can get to that. But I think the fact that now we're able to find planets, right around our sort of solar neighbor,
Yeah.
it's really exciting to see that it's not only that stars that are exactly like our sun, are the only places where you can find worlds that are like ours. But now we're starting to see that really any type of star could have any type of planet. Small planets, larger planets are popping up basically around all sorts of large and small stars at different ages. All different parts of the galaxy, all sorts of things. And so I think now knowing that, our solar neighbor, so to speak, has 3 planets means that we've moved from sort of saying, okay, maybe there's one place right next door where we could go, to now there's really a whole system that we want to get to know a lot better. And
Yeah.
I think it's going to be a really exciting place to learn some more things. Proxima is a red dwarf star, and so it's much cooler and much smaller than the sun. And that means that in some ways it's maybe not as great for life. These stars have lots of flares and lots of activity
ooh,
that do things that aren't so great, like strip the atmosphere of the planet.
ooh.
So, unfortunately, the Proxima planets might not be the best place for life, but I think they're a really exciting place to check out and start thinking about. And the fact that this new particular planet candidate is so small, smaller than the size of Earth, is really exciting because it means that we're not just going to be able to find sort of Earth analogs around these different systems, but we're now starting to push down to things that are more like Mars or even the size of the moon. And so it's really cool to get to the point where now we can start talking about these whole sort of exoplanetary systems and
Yeah.
and put them in context compared to sort of like the planets in our solar system.
Right. That's really amazing. And Proxima is actually a member, or we think a member of the Alpha Centauri system, right?
Yeah. So Proxima is part of this at least 3-star system, where it happens to be the closest to us. It's this cool red dwarf star, but it's actually orbiting. It's in a system with at least 2 other stars, which are actually a little bit more like the sun. In
Yeah.
fact, I think they're a little bit more massive than the sun,
Ooh.
and so that means they're even more bright. And recently, we found that they might be hosting their own planets as well.
Wow.
Yeah.
So it's this sort of crazy hierarchical system where you have
Yeah.
one planet is orbiting one star, which is orbiting another star, which also might have its own planets. And so it just
Gee.
goes to show the diversity of worlds that we have. You know,
Yeah.
a generation ago, people imagined worlds like Tatooine that were
Hmm. Two
orbiting
suns
over
in the
one
sky,
star.
right?
Right, and it turns out that that's totally a thing. We've now
Wow.
Wow.
found worlds like that. We've also found worlds where the planet is orbiting one star, but then there's another star that's orbiting both the planet and the star. And so,
Huh.
basically anything that you can imagine, we're starting to find. And I think this
Wow.
new planet around Proxima is a great example of that.
Wow. Science fiction predicting science fact yet again. I remember Isaac Asimov writing in his fiction about a planet that orbited Alpha Centauri. Now it looks like he was right after all. I think that's fantastic. Now,
Right.
I do want to bring up one more thing which caught my eye, and this is a very good thing because the the paper talks about it being a planetary candidate. Very careful to say, we're not absolutely sure. That's a huge part of this, of all of science, right? But in this case, especially because this is like you said, like a small planet, moon, Mars kind of thing. And so do we think that this is a really solid detection prediction that just needs to be confirmed like so many other exoplanets? Or is this one really on the edge where we think that we have to be extra, extra careful before we say with certainty it exists?
Oh, I would certainly go with the latter there. We
Okay.
exercise extreme caution, and I think the authors of the paper were right to clearly state that it's a planet candidate as opposed to a new planet. And the reason for that is, as you mentioned, or as we have mentioned, this planet is super small, and this is really pushing the limits of what we can do with our current sort of instrumentation. Uh, there's very few planets that we know of that are the size of Earth or even smaller,
Yeah.
other that are outside of our own solar system. And so any time that someone claims to have found something about that, then we really have to be careful to make sure that we do as much careful sort of testing of those targets as possible, so that we can say, is this really a planet, is it not? And a lot of times, it's important to remember that testing is not something that we can do, in a couple days, or just run
Yeah.
the data again and get a new answer. No. This is something that is going to take years of getting more data on the system, reanalyzing the signal from multiple instruments. And I think that this is a great example of why that needs to be done, because it's so hard to find these objects. But once it's done, then we can have that much more confidence that these objects are real, and really start to think about visiting these other worlds.
Can't wait to get there. That's wonderful. Now, before we go to our first question from our listeners, we have a special treat for you. And I got to say that I convinced, you could say coerced, our guest and our co-host to do this. And the reason is because I know from our conversations before we taped that Sam, Dr. Grunblatt, is an acapella meister. Uh, he
Former.
he conducted, he was the music director of an a cappella singing group in college, right? Now, what was the name of that group?
Yes, I was the music director for the Columbia Kingsmen.
Aha!
Nice.
Excellent group, a well known group, been around for a while. The reason that immediately caught my eye and why we're about to do this is because our esteemed co host, Alan, in addition to being mathematically trained, a virtual reality programmer, and author, all that kinds of amazing stuff that he does,
Yeah.
Alan also was the music director of an a cappella group in college. Not one, but two, I should say. Is
Oh,
this
wow.
not true, Alan?
That's true. I was music director for Fusion and for Harvard Glee Club Light,
Yeah.
the a cappella subset of the Harvard Glee Club. Just plugging that.
So we are going to sing in honor of Proxima, this nearby star which now may have a third planet discovered around it. Okay, so
All
give
right.
us a note, Sam.
How about like do?
Okay. Proxima. Proxima. Proxima.
Proxima.
Proxima.
You're the closest star to me, and I think you really need
Proxima.
Okay, great.
All right. We'll see what happens. Hopefully it came out well. I don't know. We'll find out in a little while. But thank you so much, Sam and Alan, for just adding a little extra something to the episode. I had a lot of fun just trying not to mess up your beautiful dulcet tones. Thank you. For now, let us move on then. Alan, do we have a question from a member of the audience, a student perhaps?
Yeah, we've got a couple of student questions today.
Okay.
The first question that we're going to ask is from Nora from New York City. And Nora says, I recently read an article about mini-Neptune exoplanets turning into super Earths. Can you explain these two terms and what exactly this discovery is?
Highly technical.
Yeah, well, Nora, that's a really amazing question. So basically, one of the so just for a little context, one of the really exciting things that we found in sort of the last 5 to 10 years of exoplanet science is that when we look and try and look for new planets around other stars, what we found is that the most common planet that we see around other stars doesn't exist in our solar system. And that most common planet is kind of in between the size of Earth and this and the size of Neptune, which is around 4 times the radius of Earth.
Okay.
And so essentially, we found all these planets that are kind of in between, and they seem to fall into sort of 2 categories. Ones which are smaller and kind of closer to the size of Earth, which we generally call super Earths because they're slightly larger than Earth, and then
Yeah.
those that are on the other side that are clearly larger than Earth but smaller than Neptune, hence the name mini-Neptune. And the idea is that the big difference between these sort of 2 classes of planets is that that the super Earths are rocky planets. They don't have very significant atmospheres, whereas the mini Neptunes are essentially gas planets. That they're mostly atmosphere. They might have a rocky core at the center, but most of what we're seeing in their radius is all gas. And so something that people have thought a lot about recently is, if we see both types of these planets, how are they related? And one of the common ideas is that planets might start out with a whole lot of gas. They might have a lot of atmosphere, but then
Yeah.
over time, the sun can sort of irradiate these planets. It can, high energy particles basically strip the atmosphere away, atom by atom, molecule by molecule, until eventually you're left with something that's just a rocky core. And so basically, that's the equivalent of turning these mini Neptune planets into super Earths by basically stripping their atmospheres and leaving behind this rocky core. And so when you read that article, I think that's probably what they were talking about. That we're seeing these planets that are unlike anything that we see in the solar system, and they're probably going from being gas giant sort of Neptune-like planets and turning into rocky super Earths over time, or through the evolution of the star and the planet system.
Amazing. Could our Earth possibly have formed that way? I'm guessing not, but I
That
mean, that
that's
would
a
be amazing.
great the formation of the solar system is like particularly tricky because we have this kind of group of small rocky planets, and then way outside, then you have all of these bigger gas giant planets. And the
Yeah.
idea is basically the gas giants sort of sucked up all of the gas in the very early solar system, leaving behind only sort of like rocky dust and debris that then turned into the Earth. So
Ah,
it's likely that when the Earth formed, there wasn't any gas, so it could never have been a mini Neptune. But
Hmm.
that's just one sort of planet formation theory. And
Yeah.
unfortunately, we can't turn the clock back, 4 billion years to see what things looked like back then. So it's very possible
That's fair.
that this is how the Earth formed, or at least how lots of other sort of planetary systems have formed.
wow,
Um,
just amazing. To
yeah,
be
that's a
continued.
great question.
I bet the geologists get really excited about this too. Like everything I learned is wrong. That's science. I love it.
Yeah.
Wonderful. Thanks so much, Sam, for that. Exoplanets, of course, are extremely interesting to people. It captures the imagination. They show up in movies. They show up in TV shows all the time. Have you seen a recent movie that you feel like had exoplanets in it, or talked about like solar system and stuff that has been fun to you, that you've kind of liked, that you want to comment about?
Yeah, sure. So, I mean, I think the sort of astronomy movie that's on everyone's minds, at least these days, is Don't Look Up. So,
Oh,
although the whole point of that movie was not really about the astronomy,
right.
it was
That's
a really
fair.
nice way to have that involved, and thinking about at least life on this planet, if not other
Yeah.
planets. And how how easy it is for some catastrophic change to really throw life in on this planet into a lurch. And
Wow.
so I think that although they don't really talk about other planets that much in that system, or
Mm,
in that movie,
right.
it sort of shows everyone that astronomy is something that's going on all the time, and we're
Right.
yeah, that research is important, and does affect life here on
Oh,
Earth.
for sure. Yeah. Now,
Hopefully in not such a catastrophic way, but
Hopefully.
now,
Yeah.
now, we don't want to spoil any significant things for our audience, right? Because if they haven't seen Don't Look Up yet, we want them to enjoy the full experience. But we can do some mild things in here and just sort of say that it is not like a disaster movie, like Armageddon or Deep Impact, where they're showing like the destruction of the world, but more like how we humans deal with science and non-science in our lives, right? And they're actually, although it's a very minor presentation of it, exoplanet is mentioned in that movie. But is your take that the science in that movie overall was generally correct, and the non-scientific predictions of what we will experience are also correct?
That's a great question. I would say so. What I can remember from the science of that movie is
Yeah.
that it's definitely Hollywoodized, so to speak, but it's pretty accurate.
Oh,
The sort of
Okay.
size of the asteroid that they're worried about, the time scale that they're worried about is
Hmm.
is not too bad. It's not too far off from what we'd actually be experiencing.
Yeah.
And
It's not the size of Texas, right?
yeah, and something that was kind of cool for me is I actually did my graduate school work at the University of Hawaii, and so
ah,
opening
wonderful.
scene they show some astronomers working at a telescope in Hawaii, and it was very cool to sort of see it and be like, oh yeah, I know where they are. I know where they.
That's great.
Um, and actually they're leading a project which is specifically designed to look for these near Earth asteroids. And so when
Yeah.
they talk about things like neos and things like this, these are
Mhm.
words that I was kind of familiar with, and I was like,
Ah.
I wonder what those folks who actually work on this stuff think about this movie.
Yeah.
Yeah, and the people sitting next to you in the theater in the couch, you're like elbowing them, right? Going, I was there. I know that. Yeah, it works. That guy.
Oh,
Yeah.
of course, couldn't let it go by without pointing it out.
Uh-huh. They're like, okay, okay, we know. Okay. Alan, do we have another question from somebody?
We do have another question. It's another exoplanets question, which is very appropriate. This is from Cody from New York, and Cody asks, in our solar system, all our planets, he writes except for Pluto, are more or less on the same plane. Is this true for other stellar systems?
Ooh, that's another awesome question. And I'm going to answer it by just saying, yeah, we don't know. Or like, yes and no. Okay, sorry, a little excited. So, what we found is that when we do find one planet that's in a particular plane, we
Mhm.
like to search for planets first in that same plane because we
Mm,
found that there are a lot of systems that sort of show very low mutual inclinations. That means that all of the planet's orbits sort of lie on that same plane, or at least very close to the same plane. So
okay.
that if we look for one in that plane, usually we get lucky and we can find more. Um, but that's not the case for all of the systems that we know about. And we've discovered at least a handful of systems now where there are multiple planets that are on very different planes. Sometimes those planes are completely perpendicular to one another.
What?
Sometimes they're just slightly, kind of inclined. And we've even now found systems where two of the planets are lined up with one another, and then there's a third planet that's on a totally different plane further out. And that in the case I'm thinking of, that third planet is kind of like the mass of Jupiter. So it's not just like Pluto where there's one small thing that's gotten knocked out of the plane,
Yeah.
but really there's some sort of crazy orbital inclination evolution that might be happening in these systems. And
Wow.
the one extra bonus of the system that I'm thinking about is that the star, I think, is misaligned from all of the planets. So
What?
all of the planets are spinning around, ending up on completely different orbits. And yeah, we don't necessarily know how they got there. Um, and just one more quick plug to the stuff that I've been working on. This is actually something that I'm really interested in
Hmm.
because, as I mentioned earlier, as planets sort of, or as systems evolve, these planets have these interactions where they can basically mess up the orbits of the planets themselves and end up on more
Mm,
eccentric orbits. And so when that happens, we think that should also knock the planets out of the being in the same plane pretty often as well. And so
yeah.
this is something that I'm like actively thinking about right now, is that when I find a system, should I look for a planet in the same plane, or should I look for a planet on any planes? Which should I prioritize? I can think of a system right now where I'm actually worried about this. So that's a great
Wow.
question.
Oh, this is wonderful. Okay, so I have to ask you, because you're an exoplanet expert, what is your favorite planet?
Oof. Uh, one of the coolest planets that I've learned about pretty recently is called it's again from the TESS mission, so it's called TOI 561. And so
Okay.
this planet is sort of one of the first planets that we found in the thick disk of the galaxy. So
Oh.
basically, all of the planets that we found, or not all, but almost all of the planets that we found so far, are very close to the sun, so to speak, in galactic terms. So they're all kind
Okay.
of in our like within 10% of the galaxy's radius from us. But this particular planet is kind of at a very strange angle where it's getting to a place where there aren't as many stars, and the actual environment in which those stars formed is quite
Hmm.
different from the one in which the sun formed and our solar system.
Wow.
And so this planet I think is really cool because despite being so TOI 561 is, I guess, the name of the system, and so the planet would be TOI 561b. But this
Okay.
planet is super cool because it's, despite being a pretty small planet, it looks now, based on some density measurements that people have made of the system, that this planet could have a very significant atmosphere, despite having a radius that's within that sort of super Earth regime. And so it's
Amazing.
kind of breaking that the our understanding between the mini Neptunes and the super Earths, because it's a super Earth that might actually look more like a mini Neptune, and that probably has something to do with it forming in this super unique environment. And so I'm really
Wow.
excited to see if we keep searching further and further, out to the thick disk of the galaxy or even the stellar
Yeah.
halo. What are the planets going to look like that we can find in these sort of extreme regimes? And can we find planets at all? That's also up for debate. It seems like the answer to that is yes. And
Okay.
the planets seem, again, even more different from our own system than we could have imagined. And so,
Wow.
as long as we keep looking, we keep finding these really cool things. And
Wow.
I think TOI 561 is a great example of that.
Yeah, and after
That's awesome.
TOI 561b, which you're talking about, if we find another one, it'll be TOI 561c, and then after that will be 561d, and you get a
Right.
whole
Yeah.
alphabet
So,
soup of planets. That's fantastic. I love it.
yes. Yes. And I should be careful. I think there is now a TOI 561c. So I hope I was talking about the right planet in the system. But
Okay.
either way, very cool system.
Wow.
Yeah.
How can we keep track of the kind of work that you do? Do you have a social media that we can find or a website that we can go look at?
I do. I do. So the easiest, or the place where I do the fastest updates, is probably on my Twitter account, and you can just find me at SK Grunblatt. So that's SK and then my last name on Twitter. And then my you can also check out my website. That's also SK Grunblatt. So skgrunblatt.github.io. And
Wonderful.
so any sort of larger updates that I have will probably end up on the website, whereas quicker things like my most recent paper I discussed on Twitter.
Okay.
Great. Wonderful. Well, Alan, thank you so much for being a wonderful co host as usual. Really appreciate it.
Yeah. Glad to be here.
Okay. And Sam Grunblatt, Dr. Sam Grunblatt, thank you so much for being here. I promise we'll find another opportunity to delve into your awesome musicality and, of course, our co host Allen Liu's awesome musicality too in the future. Thanks so much for being with us today.
Yeah, thank you so much for this opportunity. This was great.
And for all of you out there who have been watching and listening, to all of you in the audience, thank you for being with us. If you like what you see and you like what you hear and you'd like to support it, please support us on Patreon. And thank you again for being with us. As always, thank you for being a part of the LIUniverse.